Right, good evening everybody. Can you all hear me? Right, good evening everybody. Can you all hear me? If you can put in the chat, it's easier. Okay, no? Right. There was some technical issue. It streamed and stopped. Just give me a second. Okay. Right, we're good to go. Good evening everybody. This is week 3, day number 2, final countdown. Final countdown. Right. So week 3, day number 2. Week 3, day number 2. Right. So we have an electricity question to start off. We have electricity question to start off. Have a look. Now, when in capacitors we did this, this configuration is connected to Wheatstone bridge. So you can easily connect this resistor R, X terminal, terminal Y, resistor R, and connecting these two terminals you have resistor simple R. So all of you all know the Wheatstone bridge rule, the same rule which you use for capacitors. Ratio here and ratio here both are what? Same. So you can say here R divided by R, that's 1. You can say here R divided by R is 1. So center resistor completely cancels off. Now you can simplify this. You have a resistor here, you have a resistor there. A resistor here and a resistor there. That's X, that's Y. R. Resistors in series, you can add it 2R. Resistors in series, you can add it 2R. So if you work the problem out, I think I'll work the problem out here. Here on top you have resistor 2R. Here you have resistor 2R, X, Y. Now resistors in parallel. 1 over R equivalent is 1 over 2R plus 1 over 2R. common denominator 2R, 1 over R equivalent. R equivalent is equal to R. Okay, no? R equivalent is equal to R. So correct answer is answer number 2. Correct answer is answer number 2. Write the small sentence. This is a Wheaton bridge configuration. This is a Wheaton bridge configuration. This is a Wheaton bridge configuration. So the center resistor connecting terminals A and B, the center resistor connecting terminals can be removed because the potential at A and potential B at B are equal. Because A and the potential at B are equal. Because the potential at A and the potential at B are equal. Okay. Right. Okay, now moving on. Question number 2. Have a look. An object of mass m is hung by a string and is kept in equilibrium. So tension here, if this is theta, have a look. This is theta. So we can take components here. We can take components here. You have T cos theta balancing mg. T sin theta balancing the force. There's a key word here, they are saying equilibrium. Key word there, equilibrium. Which means what? Which means here sum of forces in the upward direction balances sum of forces in the downward direction. From here you can get the basic relationship. T cos theta balances mg. I'll name this equation 1. Next is sum of forces to the left balances sum of forces to the right. T sin theta balances the force F. Divide the second equation by the first equation. Divide the second equation by the first equation. 2 divided by 1. T sin theta divided by T cos theta. That is equal to F over mg. T cancel off. Tan theta is equal to F divided by mg. They are asking what's the force F. So F is equal to mg tan theta. F is equal to mg tan theta. This means your correct answer is answer number 1. Correct answer is answer number 1. Okay. Correct answer, answer number 1. Right. Okay, now moving on. Right. 2 equal masses A and B are attached by light string. The mass B moved down, held station, released. Now, if the masses are the same, remember the resultant acceleration will be 0. So if I move this slightly down, if I move B slightly down, A will be slightly up and I release it, what will happen? Acceleration must be 0. So here it will be at rest, this also will be at rest, no change. So what will happen is very simple. B will remain stationary. Right there. If the masses are equal, the resultant acceleration will be 0. If the masses are equal, the resultant acceleration will be 0. Resultant acceleration will be 0. This means wherever we move object B, it cannot start to move. Wherever we move object B, it cannot start to move. It cannot start to move. Therefore, it will remain at rest. Therefore, it will remain at rest. Therefore, it will remain at rest. Okay. Right now? So here resultant acceleration 0. If resultant acceleration 0, object will remain at rest. No change. Right. Moving up. Here you go. Two masses are joined together. They are moved by connected by a smooth. What's the tension? So what we can do is we can apply for the full system. Full system applied force 20. So if I apply here F equal ma forward for the system. So if I consider system 20 is equal to total mass 10 times A, acceleration 2 ms minus 2. Acceleration 2 ms minus 2. Now I can apply F equal ma forward. I am applying for the 4 kilogram. Tension is equal to 4 times acceleration 2. Tension is 8 Newton, answer number 2. Tension is 8 Newton, answer number 2. Right. Okay, no? Very basic but important. Right. Biot-Savart theorem. Current I flows around a closed loop. Current I flows around a closed loop, producing at the center. So you can see this is quarter of a cycle. So current going that way means field is outwards. So magnetic field at O is mu naught I divided by 2 times A times quarter of a circle. Field is outwards plus. Because of these two lines there is no field. Why? They are passing through the center. They seems like to pass through the center. From there there is a field inwards. Mu naught I divided by 2 times B times quarter into the paper. If you look at this carefully, smaller the distance, greater the field. Mu naught I over 8A outwards. Mu naught I over 8B inwards. Bring all vectors in the same direction. Bring all vectors in the same direction. B naught is equal to mu naught I divided by 8A. Change the direction minus mu naught I over 8B. Simplified. Mu naught I divided by I divided by 8. 1 over A minus 1 over B outwards. So where is your relationship there? Here you go. Mu naught I over 8. 1 over A minus 1 over B. 1 over A minus 1 over B. There. 1 over A minus 1 over B. Question number 6. A compass is placed on the top of the wire as shown in the diagram. When a large current passes through the wire, which of the following diagrams best represents the direction of the compass? Now be careful. This is O-level work. Knowing compass means north pole is directed to, so current is going on top like this. Current going that way means field inwards here. Field is coming outward there. So coming out, going in. So here is starting from here, coming out. Field is starting from here and coming out. Right. Where is your north directed to? Your north pole is directed to geographic north pole is directed to magnetic south. Geographic north pole is directed to magnetic south. Remember, geographic south pole is directed to magnetic north. So here if I connect the compass, this is magnetic south, so you have your geographic geographic North Pole here. So technically geographic North Pole is magnetic South. Geographic South Pole is magnetic North. So this variation is given by, here you go. Correct answer is answer number 4. Now if you take the Earth, geographic North, geographic South, magnetic North, magnetic South. So a North Pole is directed toward the South. So in a compass if you keep, it's directing north here. It's directed towards what? Your North Pole. Geographic North Pole directed to magnetic South. Geographic South Pole directed to magnetic North. So correct answer is answer number 4. That's right. In a compass, it indicates the direction of the geographic North Pole. The direction of the geographic North Pole. The geographic North Pole is directed to the magnetic South. The geographic North Pole is directed to the magnetic South. Okay, now? So very good question, but simple one. Nah? Simple question. Right. Question number 7. Thorium-234 emits 2 beta minus emissions followed by an alpha emission. The resulting nucleus or daughter nuclei will have. So mass number reduces to 230. 92 here becomes 90. So if you do the calculation here, mass number is number of neutrons and protons. Here number of protons. So protons 90. Neutrons plus protons, they are given 230. So how many neutrons? 230 minus 90. 140. 140 neutrons, 90 protons. Correct answer is answer number 3. Correct answer is answer number 3. Okay, now? So remember, these are very simple work. You can't get this wrong. Guaranteed you will get this correct. So be confident. Guaranteed there is marks. There is lot of marks that you can take. Right. Moving on to the next one. Right. A fossil found in to be 72,000 years old after carbon dating. Now what do you mean by half-life? Half-life is the time taken by a radioactive nuclei. So half, let's say starting radioactive nuclei X. After half-life, this becomes X over 2. After another half-life, this becomes half of this, X over 4. After another half-life, this becomes what? X over 8. Like this it continues. What are the telling you? Fossil is found. What you find at the end. Fossil means what you find at the end. Fossil is found to be 72,000 years. Half-life is 6,000. That means in 72,000 years, how many half-lives are there? Number of half-lives. 72,000 divided by 6,000, you will have 12 half-lives. Amount of carbon present in the fossil. Fossil will be X times half, 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 half. Here after one half-life, second half-life, third half-life. How many half-lives are there? 12 half-lives. 1 over 2 to the power 12. Amount of carbon present in living tissue means initially. This ratio is going to be 1 over 2 10 to the power 12. 1 over 2 10 to the power 12. Answer number 4. Answer number 4. So this is your living tissue. This is your living tissue. Number of nuclei. Number of radioactive nuclei. Radioactive nuclei. Now the radioactive nuclei keep reducing. So here x over 2, x over 4 means 2 squared, 2 half lives, 2 squared. X over 3, x over 2 to the power 3. So 12 half lives means x over 2 to the power 12. Living tissue is x. From there you can find the required relationship. Right. Okay, so 8th question, your answer is answer number 4. Right. Let's write half-life is the time taken. A very simple thing. Half-life is the time taken for a radioactive nuclei to reduce to half its value. For a radioactive nuclei to reduce to half its value. Right. Moving on. Okay. Question. Easy one. In an astronomical telescope, eyepiece of the focal length is 5 at normal adjustment. What do you mean by normal adjustment? Object is also at infinity, image is also formed at infinity, right? The separation between the eyepiece and the objective, that's f0 plus fe, that's 85 centimeters. So eyepiece is going to be 5. So focal is going to be 80 centimeter magnitude. They are asking the angular magnification, that's going to be f0 over fe. f0 is 80 divided by fe is 5. Correct answer is going to be 16. Angular magnification is 16. Angular magnification is 16. Right. Moving on. Okay. Read carefully. A uniform elastic wire is suspended vertically from the ceiling. Suspended vertically from the ceiling. And a mass is hung at the bottom. So the mass, there will be extension taking place. Small extension taking place. Consider the following statements assuming the proportional limit is not exceeded. Right. If the length of the wire is double, the strain in the wire doubles. Now proportional not exceeded means cross-sectional area will not change. Area does not change. Remember, in plastic deformation, you have elastic deformation, plastic deformation. Only in plastic deformation, cross-sectional areas will change. Right there, small sentence. When a metal deforms, there is an elastic region as well as a plastic region. There is an elastic region as well as a plastic. Plastic means not plastic actual. You call this permanent deformation region. There is an elastic region as well as a plastic region. It is given that the object is in the proportionality limit. It is given that the object is in the proportionality limit. Which means the cross-sectional area will not change. Cross-sectional area will not change. Right. First one. If the length is double, the strain will double. The equation strain extension divided by initial length. When the length of the wire is double, the strain will double. Length is double means, what's your extension? 2L minus L, initial length is L. What can you say about the strain? Strain does not change. Statement A is wrong. So whatever with statement A is wrong. If cross-sectional area of the wire is double, the strain of the wire will double. Cross-section area has nothing to do with strain. There. Stress will reduce, so the same force. So these also wrong. If the hung mass is double, the strain in the wire will also double. Right? No? Young's modulus is stress divided by strain. Young's modulus into strain, that is equal to stress. Here force divided by area, Young's modulus into strain. Force equals weight mg divided by A, Young's modulus into strain. So proportionality limit, area is not changing, G is not changing. Young's modulus is for the metal constant. So mass is proportional to strain. By any chance, if the mass is double, automatically the strain will also double. C correct, only C correct, answer number 3. Only C correct. So B wrong, no? So this is wrong, means that is wrong, only C correct. 10th one, answer 3, right there. This we wrote, next one. The cross-sectional area is not related to strain. Is not related to strain. Okay, we'll do like this. Cross-sectional area is related to strain, but inversely. If it increases, strain will reduce. If the area increases, strain will reduce. Right. What's the next one? If the mass is doubled, the strain will double. I have shown here. Mass proportional to strain. Mass is proportional to strain. So when the mass doubles, the strain will also double. So when the mass doubles, the strain will also double. Okay? Right. A steel razor blade is made to stay on the water surface because of surface tension. Staying of the steel blade on the surface of water contradicts Archimedes' principle because there is no upthrust acting on the body. This is wrong. You know why? The blade is not submerged. Archimedes' principle is valid only when the blade is submerged. Blade is not submerged. Therefore, you can't apply Archimedes' principle. Right. Steel razor blade is kept on the surface of water by forces due to surface tension in water. Correct. Adding soap to water, what happens? When you add soap to water, surface tension will what? Reduce. So if you add soap, you are reducing surface tension. Now, when you put soap and wash your clothes, what's happening? When you put detergent powder, wash your clothes, what's happening? The powder will reduce the surface tension effect, easily removing the dirt. Okay. So, C correct, B and C correct, answer number 5. B and C correct, answer number 5, right there. When soap is added, the surface tension reduces. When soap is added, the surface tension reduces. When soap is added, the surface tension reduces. Causing the razor blade to sink. Causing the razor blade to sink. Right. So far, how it's kept? Because of surface tension. So if surface tension reduces, it will sink. Okay. This one. Air flows through. Now here, large area, low velocity. Small area, high velocity. Velocity of y is greater than velocity of x. Pressure of y is less than pressure of x. what will happen? So when air is going from P to Q, larger pressure means greater height for the ping pong ball. Smaller height means there you go. So the ping pong ball will fly higher near X than Y. Okay. From this it's very clear, answer is answer number 1, right there. From Bernoulli's principle, at Y the velocity is high. From Bernoulli's principle, at Y the velocity is high. Therefore the pressure will be low compared to X. Therefore the pressure will be low compared to X. Right. Question number 13. Object moves in a circular path. So this is a cone. Normal reaction is there. Weight is there. That's about it. They are telling you smooth conical shape, no friction also. So what are the forces as observed by a stationary observer? Somebody outside is looking at this. What will he see? He will see normal reaction, weight. That's a different story. Component is giving centripetal. But normal reaction, the force you can see is normal reaction, weight. Weight of the object and the normal reaction force. Correct answer, answer number 2. 13, answer number 2. Answer number 2. This one. Weight W is hung. So here tension is there. This angle here is going to be theta here, theta there. So if that is theta here, I can make this is theta here, this is theta here. Simplify it now. T cos theta, here T cos theta. T sin, 2T sin theta. Right. So if it's in equilibrium, sum of forces in the upward direction balances sum of forces in the downward direction. 2T sin theta is equal to W. What are they telling you about the tension? Tension equal W divided by 2 sin theta. Look below. Theta small means sin theta is also very small. Sin theta is very small means T is greater than W. Tension is larger than W. Tension is larger than W. So when theta reduces, sin theta reduces, tension will be larger than W. Right. So these are things that you have done, but it's good for you to remember. Question number 20. Question number 20. A child of mass 20 kg swing is attached to a pivot of 2 ropes. I like this. Child is sitting and coming. Now this reaches the lowest point. So she is holding both. So metana mama tension 2T kila danna. So here 2T, don't forget. So this tension T, I have put here as 2T. Swinging here. Mg here is going to be 200 newtons. There you go. Speed there is going to be, lowest point speed is going to be 3 meters per second. Right. So if you are going in a circular path, there will be a centripetal force. Centripetal force, mass into centripetal acceleration, acting towards the center. 2T minus 200, mass into acceleration v squared divided by r. Radius is also 3 meters. Simplify it, 2T equals 260, T equals 130 Newton, there you go, 130 Newton. So tension is 130 Newton, correct answer is answer number 1. Answer number 1. Right there. The centripetal force at the lowest point is provided by. The centripetal force at the lowest point is provided by both the tensions and weight is opposite to it. Both the tension and weight is opposite to it. Okay? Right. Given mass of water in a calorimeter, 90 watt heat is immersed. The temperature of water increases, comes to a steady state. There you go. Immersion heater heats. Temperature remains constant at 35. That means what? Rate in which heat is supplied and rate in which heat is lost, both are what? Same. Write a small sentence. When the temperature of the beaker becomes constant when heating. When the temperature of the beaker becomes constant when heating. That means the rate in which heat is supplied. That means the rate in which heat is supplied so right now, rate in which heat is given and lost, both are same. Look at the board now. Q dot is equal to K times A excess temperature. So here 90 watt supplied, 90 watt loss. K same area. Theta is 35, room temperature we don't know, equation number 1. Now your next situation what? 180 watt heater. 180 watt heater. Temperature is constant at 45. Rate in which heat is supplied equal rate in which heat is lost. 180 is equal to K times A. 45 minus theta R, equation 2. Divide the second equation by the first. 180 over 90 equals K kapano. 45 minus theta R divided by 35 minus theta R. Okay, no? 90 times 1, 90 times 2, cross multiply. 70 minus 2 theta R equals 45 minus theta R. So here you have 25 degrees Celsius. That is equal to theta R. What should be the room temperature? 25 degrees Celsius. Answer number 4. 16. Answer number 4. Right now? Right. So remember, temperature constant means rate in which supplied and rate in loss both are same. Right. Okay. An object is placed on the principal axis 31 centimeter from the concave mirror to the image formed in a slightly smaller than the object. If the object is placed 29 centimeter from the mirror, the image is larger than the object. Now remember this. This particular question from your O-level knowledge. Okay? From your O-level knowledge. Here you go. Optical center. Right. If an object is placed on the principal axis 31 centimeter from the mirror, image is found to be smaller. So light rays go, image is found to be smaller, right? If the object is kept closer, the image is larger. Yes. What is the approximate focal length? What is the approximate focal length? So right, now how are you going to calculate this? Well, best option is this is 31 centimeter. Somewhere here this is 29 centimeter. So your center is occurring somewhere between 31 and 29. So center we can say 30 centimeters. So what's the focal length? Center divided by 2, radius of curvature over 2, 15 centimeters. So 17th one, correct answer is answer 2, right there. As shown in the figure, if the object is kept beyond the center, if the object is kept beyond the center, the image formed will be small. Image form will be small. And if the object is kept at 29 centimeter, and if the object is kept at 29 centimeter, the image will be a magnified image. Therefore, we can estimate that. Therefore, we can estimate that the center is at 30 centimeters from the mirror. The center is at 30 centimeters from the mirror. Which is half the focal length. Which is half the focal length. Okay. So this is actually from your what knowledge? O-level knowledge. O-level knowledge on mirrors. Right. A glass cube 24 centimeters has a refractive index 1.5 and contains a small air bubble. When viewed from one side, air bubble appears to be 12 centimeters there. So image is there. 12 centimeters. When viewed from the opposite side, how far will the appear? Let's say distance x, independent of the place where you keep your eye. So image will come closer, y1. So here you can say refractive index is real depth divided by apparent depth. Real depth x1. Real depth is x1, apparent depth is 12 centimeters. Refractive index 1.5. So x1 is equal to 18. x1 is 18. So how much is x? X is 24 minus 18. How much? 6. So x is 6. Now refractive index over apparent depth y. Refractive index 1.5. X is how much? Y only we have to find. 6 divided by 1.5, 4 centimeters. So how much will it appear from the other side? 4 centimeters. 18th question, answer number 5. 18th question, answer number 5. Right. So the equation is N real depth over apparent depth. So refractive index is real depth divided by apparent depth. Right. MCQ 90. A rocket has liquid hydrogen 1.8 10 to the power 4. 1.8 10 to the power 5 Newton directly. Vertical tank area is given. At lift, the rocket accelerates vertically with 2 ms minus 2. Please correct this. This should be 2 ms minus 2 relative to the earth. The pressure on the bottom of the tank is, so there is a liquid tank. Right. The pressure at the bottom of the tank at liftoff is. Okay. Simplify this carefully. So what happens is, when this accelerates, there will be a pseudo weight toss acting. 1.8 10 to the power 4 times 2 in the opposite direction. So total pressure is equal to total force over area. Total force, so when you accelerate, there is a weight tosser and there is a pseudo force both acting. 1.8 10 to the power 5 force. Because of this pseudo force, mass into acceleration, 3.6 10 to the power 4. (18 10 to the power 4), 3.6 10 to the power 4. 21.6 10 to the power 4 Pascal. Sorry, force. Right, luckily we looked at it, it's force. So what's your pressure? 21.6 10 to the power 4 divided by area, 3. 7.2 10 to the power 4 Pascal. 7.2 10 to the power 4 Pascal, answer number 5. Answer number 5. Right there. When the lift accelerates, there will be a pseudo force acting on the liquid mass. There will be a pseudo force acting on the liquid mass, pressing it further downwards. Pressing it further downwards. Thereby the total force is the weight and the pseudo force. Therefore the total force is the weight pseudo force. Weight and the pseudo force. Right now. Right, question number 20. Right, look. Here you have M1G. Here total weight capital Mg. Length L, here tension. Here because of this weight there is M2G. Here wedge is pushing the block upwards, block is pushing the wedge, or the wedge is pushing the ruler upwards, ruler is pushing the wedge downwards. There you go. What are they asking? Show the force acting on the spring balance. So clockwise moments about B equal anti-clockwise moments about B. Clockwise moments is going to be, clockwise moments is going to be tension times L. I keep here R1 won't come. Anti-clockwise. mgl plus m1g into from here to here. How much? 2L. They are asking tension, all the lengths will cancel off. Tension equals capital Mg plus 2m1g. M plus 2m1g. Correct answer is answer number 4. Correct answer number 4. Right now? So if I timed it today from exactly 9:30, 10:20. So discuss 20 MCQs averagely around 30-20, no 30-20, around 50 minutes. So around approximately, approximately how much? 50 minutes. No? So generally for a question around 20 MCQs, 50 minutes. 1 MCQ around how much? Around 2.5 minutes. So I am verbally giving you notes as well, so this much. So you should be able to do it for lesser than that. Right. Okay. A student plans to perform an experiment in the laboratory to study the variation of saturated vapor pressure. That's the key word. Saturated vapor pressure. Complete the following diagram of the arrangement. Now this is like what? You are trying to find the saturated pressure. No? Clear? Saturated pressure. So trying to find pressure means, we can trap a mercury column inside. We can trap a mercury column inside. Right. Now if you want saturated vapor, here saturated vapor, they are saying water thread. Okay, that means forget about the mercury. So they want a mercury thread, water thread. So here you go, the beakers. There you go. From this connect the linear scale. From this connect the linear scale. There you go, linear scale. So complete the following diagram. Thermometer is required. Stir. There you go. Right now. So linear scale, you can name them if you want. I'm sure you should name it. Linear scale. Stir. thermometer. Right. Okay. How does the student insert water into the tube? In the form of water thread. Same as you insert mercury. What do you do in mercury? Can you remember what do you do in mercury? Insert the tube into water. Insert the tube into water. There you go. Look, 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 look. Insert the tube into water and heat around it. When you heat around it, the air will go away, creating a low pressure. Outside high pressure, low pressure, there's a push, liquid will rise up. So you're heating it around. So you heat it around. So once you heat around, the air will heat, expand and go out. Low pressure created. High pressure, low pressure, there's going to be a push. Right there. We place the tube such that we heat the tube and the open end is inserted into water. This creates a sudden push for the liquid to rise in. This creates a sudden push for the liquid to pass through. So the same way we can use what? For mercury. So heat around, insert into water, suddenly cooling, suddenly there is going to be a sudden water thread jumping in. What is the best position for the water thread to be located inside the tube? At room temperature. Where? Is it closer to the open end, at the middle, or near the end? So technically at the middle. Why at the middle? When we heat it, the liquid column will rise, or the liquid thread will rise. So to obtain many readings, it's easier to obtain many readings if the liquid can travel inside the vessel. So what happens is, if you do not keep it in the middle, once you heat it, the liquid will jump out. Right there. When we heat the tube using water, when we heat the water tube in water, the water thread will travel along the tube. I am writing the reason here. Huh? The water thread will travel along the tube. And if it's near the open end, it will jump out. If it's near the open end, it will jump out. If it's near the open end, it will jump out. Therefore, we will not be able to do the experiment correctly. Therefore, not be able to do the experiment correctly. Because the water thread should always be underwater. Because the water thread should always be underwater inside the tube. Water thread should always be underwater inside the tube. Right. Write down the steps required to carry out the experiment. So what do? To increase the temperature, what we did was normally increase the temperature by 10 degrees Celsius, remove the Bunsen burner, stir, maintain the particular height, and measure the length of the air column. Repeat this for many different readings. Right there. we increase the temperature of water. We increase the temperature of water and continuously stir. And continuously stir. And continuously stir. This causes the trapped air to expand. This causes the trapped air to expand, pushing the mercury thread up. Pushing the mercury thread up. Pushing the mercury thread up. So for every temperature of the air column, for every temperature, we measure the length of the air column. Right? So for different temperatures, you measure different lengths. Okay, no? At temperature θ1 and temperature θ2, the lengths are L1, L2. SVP is P1, P2. Atmospheric pressure is P. So looking at this very carefully, look at the tube. Water thread is here. I'll mark that in red color maybe. So here you have atmospheric pressure, capital P. Here there will be a mixture of water vapor and dry air. Water vapor means P plus. Pressure due to air, we don't know. Pressure due to air. So we can say P is equal to P1 plus pressure due to air, because the thread is very small. So pressure due to air, that is P minus. Same way, tube is there. Let's say there is a water thread. Atmospheric pressure is P. Saturated vapor pressure is P2 plus air pressure at the second instant. Here temperature is θ1 Celsius. Here temperature is θ2 Celsius. The length is negligible, so we can say P is equal to P2 plus air pressure. There you go. Air pressure is P minus P2. There you go. It's P minus P1. That is P minus P2. Okay. So somebody might ask, can't we apply H rho G? H is very small. H is very small. You can't apply H rho G. Directly you can say P balances by P1 plus air pressure at that particular instant. Okay. Write down equation connecting all of this. So we are applying for air. For dry air you can apply. P1 over T1, P1 V1 T1 equals P2 V2 divided by T2, right? Pressure of air is P minus P1. Cross sectional area into L1 temperature is θ1 plus 273. Here P minus P2. A times L θ2 plus 273. P minus P1 L1. θ1 plus 273. P minus P2 L2 divided by θ2 plus 273. There you go. Remember, you are applying gas law for only air. You can't apply for saturated vapors. Right there. We can apply gas laws only for unsaturated vapors or air. Only for unsaturated vapors or air. Or air. Okay. Moving on. Draw a rough sketch of the variation of saturated vapor pressure with temperature. Curve like this. Curve like this. You have done this in humidity. Okay, now passage question. Passage question. Now the trick or the art of doing the passage question is never read the passage fully. Don't read the passage fully. So what you should do is go to the question and then find the answer here. Right. What is the normal audible range for humans? Go and see what are they saying. So by definition, audible range is between 20 to 20 kilohertz. Yeah. Audible range 20 to 20 kilohertz. Like that. 20 to 20 kilohertz. Right. 20 to 20 kilohertz. Right. Not difficult. So in a paragraph question, don't read the paragraph and start. You just have a skim through the paragraph, but start from the question. Find the answer. Next one. State 2 advantage of using an ultrasound in medical diagnosis. Right. Let's do. Use of ultrasound in medicine have several advantages. The low intensity beams used are not known to produce any damage or undesirable effects to humans. Ultrasound does not ionize atoms or molecules. Ultrasound is also reflected by objects of small size. So why are you using it? These are the reasons. Low intensity beam used are not known to produce any damage. Next, unlike X-rays. X-rays, right? You can answer this. Does not ionize atoms in human cells. So this is your answer. I won't write it, I'll just show it there. This is your answer for, and here even this. Ultrasound reflects small objects. This is your answer for Roman number 2. Answer for Roman number 2. Roman number 2 answers. Roman number 2 answers. Okay, no? Roman number 2 answers if you want in black itself, right? Finished. No? Roman number 2 answers. 3. Low intensity. Does not produce any undesirable effect. Does not ionize atoms or molecules. Also be reflected by very small objects. Right. Okay. Next. So we have done this. Don't forget. We have done this. Right. Next. Is ultrasound longitudinal or transverse? Ultrasound, sound wave. Sound waves are always what? Longitudinal, right there. This is a sound wave. This is a sound wave. Therefore, it is a longitudinal wave. Therefore, it is a longitudinal wave, right? What is the main differences between sound and ultrasound? Main difference between sound and ultrasound. Right. So ultrasound. So here they are asking you, wait, I'm finding what is the major difference between sound and ultrasound? The major difference is this though. Ultrasound is greater than 20 Hz. Sound is between 20 to 20,000 Hz. Right? Ultrasound is greater than 20 kilohertz. Ultrasound is more than 20 kilohertz and the audible range is less than 20 kilohertz, between 20 to 20 kilohertz. Okay, now? Right. I think I have answered there also. There also, I think the answer for Roman 4. Roman 4, right? Is ultrasound electromagnetic? Answer is no. Ultrasound can't be electromagnetic. Why? It is a longitudinal wave. Is ultrasound electromagnetic? No, it is a longitudinal wave. It is a mechanical wave. It is a mechanical wave. So it's mechanical, otherwise it doesn't travel at the speed of light in the vacuum. That is also a good answer. This one is also okay. No, it's a mechanical wave. It does not travel at the speed of light in a vacuum. Right. Okay. Calculate the wavelength 50 kilohertz ultrasound in human soft tissue. So 15 megahertz is given. Our job is to find the speed, no? Right. Fairly for human soft tissue, the value is 1005. Speed of the ultrasound in air is about 300. Densities of air and soft tissues are fairly different. Therefore, skin interface reflects about 99% of the incident ultrasound. This will be eliminated in the test carried out. So 1500. If you simplify it, V is equal to F lambda. In human soft tissue, 1005 mega lambda. Lambda is 100 10 to the power minus 4 meters. 10 to the power minus 4 meters. Right. Give a reason as to why ultrasound is also reflected from small objects. So reflection means, look, reflection means it's knocking and coming back. Why is it knocking and coming back? So the wavelength here is almost same as the size of the object. So once it's knocking on a barrier. Wavelength, let's see if they are given that. Right. So here wavelength is similar to the size of the object. Therefore, reflection occurs. Right. Use the following steps to derive the formula of FD given in the passage. What is the component of the velocity of the red blood cell R along the direction of the device T? Right. Now be careful when you do the work. Velocity here, so the velocity in the direction of V is V cos theta. V cos theta. Okay. This component is V cos theta. So if you move up, right, V cos theta, right. Consider the device. So what is this FD? What is this FD? Transmits, receives FR. Difference between transmitted and received is called Doppler FD. Okay. Right. Consider the device as stationary source and the red blood cell is moving observer. Write the expression for the frequency detected by the cell. Right. Cell is the observer. Cell is the observer. Here velocity V. V cos theta. Now this is your observer. Sound will come and knock on this. Sound is traveling with a velocity. Velocity of sound is given in symbol form, use that same symbol. U is the speed of the ultrasound, right? Sorry. Right. Okay. Ultrasound waves are coming at a speed u. Right. So what is f dash? Velocity of sound with respect to the observer. U plus v. Velocity of sound with respect to source into actual frequency, transmitted frequency. Transmitted frequency. Okay, no? Right. Now consider the cell. I have taught this in Doppler effect. Even when reflection occurs, the ball will act initially like a temporary observer, then like a temporary source. Simple. But let me draw this, very important. Now the cell will start reflecting whatever it got. F dash. Here V. Here there is a component V cos theta. Now this is the source, this is the observer. Sound is going to travel from the source in that direction, ultrasound speed. What is the frequency received? Velocity of sound with respect to observer. Observer is anyway at rest. Velocity of sound with respect to source. Make the source stationary. U minus V cos theta in F dash. U divided by U minus V cos theta. F dash. Here you go. U plus V cos theta divided by U Ft. U cancel off. From this you can say received is U plus V cos theta divided by u minus v cos theta into transmission. Combine the above two expressions and obtain. Combine the above two expressions and obtain. Right. Okay. Is received minus transmitted. So received is, they are asking you to prove the relationship in terms of transmitted. U plus v cos theta divided by u minus v cos theta ft minus ft. Common terms take it out. U plus v cos theta divided by u minus v cos theta minus 1. If I cross multiply, minus u plus 2v. So 2v cos theta ft divided by u minus v cos theta. This is your Doppler effect. Doppler effect. Since v is very small compared to u minus v cos theta can be approximately equal to u. So here I can say 2v cos theta ft u minus v cos theta, that is equal to u. Okay. Okay now? Right. For 15 kilo megahertz, FD was found to be 8. Calculate V for the red blood cell. Take theta to be 10. Take theta to be 10. So let me do the substitution here. Now you know the equation. Yeah. FD is equal to 2V cos theta divided by U F transmitted. 2 times V cos 10 transmitted 15 megahertz. U is 1500 FT. Simplify it. Doppler 8 kilo. 8 kilohertz. 15 times 100. 10 to the power 5. 8 10 to the power 5. 10 to the power 6. 10 to the power 5. Right. 15 times 1, 15 times 100 goes there to 8 10 to the power 5. 8 10 to the power 5. Two cos 10 V (15 10 to the power 6). So 8 10 to the power 5, 30 V cos 10, 15 10 to the power 6, 10 to the power 1 there, this whole thing goes. 8 divided by 300 into 15 into cos 10, that is equal to V. So 8 . What's the value for cos? Carefully turn back and look, theta. So cos 10. Smaller the cos 0 is actually 1. These approximately 1. From this V you can say 8 divided by 300 times 50. So 8 300 times 15, 15 times 1 0. For 80 you have 5. For 50 you have 3. 0.001. 0.001. 2337. So if you calculate the velocity here will be very small. So here 1, 30, 1500 to 4. So 8 there. Let's check the calculation here. Right. Let's erase this. I'll quickly calculate it with the approximate value. So here your answer will be how much? This is almost 1. So 8 15 times 100, 4. Check and see the answer is 0.4. Getting 0.4. Yeah, around 0.4 you will get. Around 0.4 you will get. Why is it desirable to keep theta as small as possible? So what happens is, if theta becomes large, cos theta will become small. If cos theta becomes small, the denominator will become large, no? So cos theta will become small. This is small, difference is large. Again look. So here cos theta becomes smaller. When cos theta becomes smaller, when you multiply, it's going to be small value here. Difference is going to be large. So why is it desirable to keep theta as small as possible? Smaller the value of theta, what happens is, if theta becomes small, so if theta becomes large, This is going to be smaller value. Difference is going to be large. FD will be small. That was you can write. So FD is small. That's right. When theta is large, cos theta will be small. This part will be small. Difference here will be large. Large means your Doppler effect FD will be small. Right there. By having a larger value for theta, FD will reduce. By having a larger value for theta, FD will reduce. Okay now? Right. What is the purpose of using coupling gel? Now you have seen, if you go for ultrasound, they'll put gel. What's the reason? Right. Now, carefully look. Here, soft tissue is fairly different, therefore skin interface reflects 99%. 99% reflection is taking place. So why do you put a gel there? To stop reflection from taking place. So right there, to minimize or stop reflection taking place. Okay, no? Right. Right, okay. So this session is easier. You also learn the technique how to solve what? Paragraph type problems. Never ever read paragraphs and then do. Start from the question. Just get a small idea what it is about. From the question you try to find the answer. Remember, sometimes answers are not there in the paragraph. You will have to write logical answers depending on what your theory. So normally the essay question seems people tell it's easy, but remember it can hide a lot of information and you should be very careful to get those information into your answers. Okay now? Okay then, week 3, day 2 done and dusted. Tomorrow I'll see you with week 3, day 3. Make sure you do the questions, do the paper, and even though tomorrow is holiday, make sure you keep on working. There is no time to relax. Absolutely be at it. Go 100%. Keep going 100%. So you know that you're always reaching your general benchmark that you need to do every day. Okay then? Right. Stay home safe. Good night.